Hello, everybody. I'm never quite sure when the recording starts, so I just awkwardly smile for a while before I start talking. And now you know. Today, I'm going to take a few minutes to go over some IB style questions that are a little bit more difficult than the examples we did in class last time. What I would like us to focus on are the strategies that we use and trying to make sure we know which formula to use in which situation. And before I go through each of these, it would really, really benefit you to pause the video and to try the problem yourself for at least 3 minutes. Now, you might be able to go on longer than that. If you are, great, keep going. But you should spend at least 3 minutes doing your own thinking before you watch me solve these problems. Now, they are difficult, and these are probably harder than any problems you're likely to see in the homework packet that I've given you. And when I say homework packet, I'm just saying words. Please remember, you don't have to do every single problem in those giant packets. They are just there for practice. You do need to practice, though. So after I'm done going through these tricky examples, go back to the sequence and series packets, the arithmetic one, the geometric one, and try some of the harder problems. Hopefully you've had a chance to try some of the easy ones by this point. Go a little bit deeper into the packets. See if you can find something challenging. I'm going to pull up my slideshow. Okay. That is, let's see, something weird is happening right here. Not sure what you're seeing. Oh, I'm trying to record twice. Sorry, this is great video content, I know. Let me just go to the slideshow. I could start over, but nah. So here's one of the questions. Take a second, read it, underline important words, look back at the formulas, and then try to solve for D and R. At least get started. Take 3 minutes, pause me. Okay, I hope you at least figured out the right formulas to use. We'll see. So we've got the first, fifth, and 13th terms of an arithmetic sequence, and they have a common difference of D. So we don't know the common difference, in other words. Here, let me get a little a pin. Okay. And those same numbers are also the first 3 terms of a geometric sequence. So we're going to be using the arithmetic sequence formula and the geometric sequence formula. Specifically, when we talk about a sequence, we mean like the nth term formula, the general term formula for each of those sequences. And we don't know all the values of those 3 terms. We know that the first term in each sequence is 12. And we know that the first, fifth, and 13th terms of the arithmetic sequence match the first 3 terms of the geometric sequence. So let's just write out what we know first. Oh, and there are the formulas for reference. So we could write the first, fifth, and 13th terms of the arithmetic series in this way. So the first one is 12. And then the fifth term would be 12 plus n minus 1. So n would be 5. So 5 minus 1 times d. So 12 plus 40, that's the fifth term. And then 12 plus 12d would be the 13th term using the same formula from above. So that's for the arithmetic series. I'm going to put an A next to it. Those would be the 3 formulas for the 3 terms. Now these are the first 3 terms of the geometric series. I'm going to put a G. We're using this geometric formula up here. So the first term is 12, and then for each successive term, we multiply by r once. So 12 times r, 12 times r squared, or you can plug 1, 2, and 3 in for n in this formula above. Same thing. So now that we have a way to represent these first three terms, we have some things that we know have to be equivalent. So the first term of the arithmetic series equals the first term of the geometric series. And that's cool. They're both 12, but 12 equals 12 doesn't really help us solve an equation for r or d because it doesn't have r or d in it. So let's move on to the next one. We know that 12 plus 40 has to equal 12r because those are the same term. The fifth term of the arithmetic sequence is the second term of the geometric sequence. And then the 13th term of the arithmetic sequence has to equal the third term of the geometric sequence. So because we have two variables here, we have d and r. Anytime we have two variables, you're going to have at least two equations to solve those two variables. So here are our equations, and maybe somewhere back in the recesses of your mind, when you see these two equations with two variables, you think, I need to either use substitution or elimination. And maybe not, but it's still true. Those are the two main ways that we solve systems of equations. So this is a system of equations, two equations with two variables. I did this with elimination because these are already sort of set up to make elimination pretty easy. By the way, this 1 and this 2 are just names of the equations. This is a common way to label equations in mathematics. You put a number next to the equation in parentheses. It's not multiplication. And then you can refer to that equation. So you can say dividing equation 1 by 4, and that just makes it easier to talk about the equation because it's labeled. So we divide that one by 4, divide the second equation by 12, just to set these numbers up. And if you remember elimination, you want to either add or subtract the two equations together. In this case, we're going to subtract the bottom equation because when we subtract d minus d, the d's get eliminated. And we get a simpler equation that only has one variable. And that's basically this equation right here. So that's what I get when I subtract this top equation minus this bottom equation. 3 minus 1 is 2. 3r minus r squared is 3r minus r squared because those don't simplify. And this might look familiar. Again, things you've talked about in previous math classes, but is it still in there? Hopefully somewhere. This is a quadratic equation. The r squared would be the giveaway. So move everything to one side, set it equal to 0, and either factor or use the quadratic formula. Sometimes factoring is easy, sometimes it's hard, but you have those different options. I guess you could complete the square too, if you really want to. And then once you have it factored, set each factor individually equal to 0. So r could equal 1, except that it can't equal 1. Or r could equal 2, because 2 minus 2 is 0. So r equals 2 has to be the right answer, because we're specifically told that r does not equal 1. Now we found r, we didn't find d, so don't forget to go back and solve for the other variable by taking the one you found and substituting it in to any of the equations. It doesn't matter which one. Pick the simplest one. Equation 3 over here looks pretty simple, so I could take my r value and plug it in for r and then solve for d. But again, it doesn't matter which equation I use. I can use literally any of them. Here it is using equation 4. I guess that one's pretty simple too. Okay, feel free to pause me and write stuff down. I'm going to move on to the next question here in real life. Okay, this one has 3 parts. Now, something to keep in mind here, the way that IB questions are written, you can always answer part B without being able to actually answer part A. And you can answer part C without having answered part B. So don't look at part A and think, oh, don't know how to do it. I'm out. I can't do anything on this problem. That's not true. I'm still going to go through them in order, but as you after you pause this and take a few minutes to look through this and try, I think you'll be able to make good progress, maybe on part A and B, if you can recognize what type of series this is. It's arithmetic. So pause me, take a few minutes. Wow, great job on this problem. Now let's see how well you did. And by the way, reading this is a little bit confusing. I put this line in here just to make sure we see that the words underneath B actually pertain to part C. So all this goes together. That might have been a little confusing. I should have told you that before I gave you time to work on the problem. I guess you can pause it and try again. I'm going to go through part A. Find their sum. So this is a sequence of integers which are divisible by 9, which means they're going to be 9 apart. 9, 18. Of course, 9 and 18 don't count because they're not between 20 and 30, but 27, 36. So this is an arithmetic sequence because the numbers are 9 apart. There's a common difference of 9. So the first term is 27. The common difference is 9. And you have to be able to recognize that to use any of the formulas we're going to use. So we also, before we use this next formula, we need to know the value of n. So in other words, how many of these numbers are there? The first one is 27. The last one is 297. So there are different ways you could do it. This just means to round down. This is a floor function. So if you take 300 and divide it by 9 and then round it down, you get 33. Then you subtract 2 from the 9 and the 18 that are missing at the beginning of the sequence, and you get 31. You could also, if you notice that 297 is the last number, you could just do 297 divided by 9, and then you don't have to round. So there are 31 terms in this sequence, and that's important because for the sum of an arithmetic sequence formula, we need the value of n. Here's the formula right here. With n as 31, the first term is 27, the last term as 297. Plug those numbers in, and you get that. Part B. Oh, sorry, part A wasn't over. Alternative, you could use the other formula, which is equivalent to this one, like we talked about yesterday. Yeah, you get the same answer. Either formula. Part B. So all we want to do here is express the sum using sigma notation. Sigma meaning, nope, I already messed it up. Sigma meaning, oh, and now my mouse is messing up. That's okay. The big Greek letter. All right. Some things we already talked about on part 1, although you could have figured these out just for doing part B if you hadn't completed part A. But it's still important. We've got an arithmetic series this time because we're adding the sum together. First term, common difference, certain number of terms, and we're going to use the sigma notation here. So to use the sigma notation, remember we put a big sigma there. You probably drew it better than I did. We say where to start. So we're starting at n equals 1. Now we commonly used I here. It doesn't matter. It's just a letter. So if you wrote I, that's fine. That means you're going to have an I over here instead of an N. So we start with the first term, we end with the 31st term, and then in these parentheses right here is our general term formula. So a u sub 1 plus n minus 1 times d. Writing's not going well, so I'm just going to stop writing that. Okay. Next part. We could simplify it, but you don't have to. So if you distribute the 9 and combine like terms, and then factor out a 9, you get this. You don't have to simplify your answers in general unless you're asked to. Now for part C. So as you can see, we've got some extra information to use here. It's almost like it's a totally different problem. So an arithmetic sequence has a first term of -500 and a common difference of 8. Hey, at least they told you it was arithmetic this time. That was nice. So we know which formulas we should be using. And it tells us something about the sum. So make sure we're using the sum of an arithmetic sequence formula in there somewhere. And even if you just write that formula down, you might get a point for that. So here's that formula in one of its two forms. Doesn't really matter which one you use, although the nice thing about this form is that you actually don't have to know what the last term in the sum is. And that can simplify your life a little bit, but it doesn't really matter. So we know our first term, we know our common difference. We know that the sum is supposed to be bigger than 0. And so instead of setting it equal to 0, we set it, sorry, I said bigger, I meant smaller. The sum is supposed to be smaller than 0 because it's negative. So instead of setting it equal to 0, you set it as less than 0. Now you could do the algebra and set it equal to 0, do the algebra that way, and just adjust your answer at the end to make sure your answer is smaller than 0. And that would be totally justifiable as well. You don't have to write it out like this. So we plug in the numbers that we know. We don't know n, but we do know u sub 1, and we do know d. And because we only have one unknown variable in this equation, we only need this one equation to solve. We don't have to do substitution or anything like that, like in a previous problem. One variable, one equation. We can just do basic algebra. We'll distribute, combine like terms, etc., etc. And you can solve this with a graphing calculator as well, or you can just do the algebra. There we go. So n is less than 126. So that means n is 125 because the number of terms in a sequence has to be an integer. And our answer was supposed to be less than 126. So the next integer down is 125. And if you solve this as equal to 0 and you got n equals 126, that would tell you that the 126th term actually makes the sequence add up to 0. And so round down. Okay. This has been a great time for everybody. What I would like you to do now, there's plenty of class left. You've got a lot of questions in that question bank, and you have other people in your class who need to practice just as much as you do. So what I would like you to do is to pair up. Find a buddy. if there's an odd number of you, which there could be, find another buddy. And what you're going to do is challenge your buddy by trying to find the hardest problems in these sets of problems that you can find. But if you're too harsh, your buddy is also going to get to pick a problem for you. So your buddy could be mean back. How do you feel? Do you feel mean? Do you feel nice? Do you want to fight? You want to get along? I'll let you and your buddy, and possibly your other buddy, decide that. But that is what we're going to do for the rest of this class. So hopefully you actually spent some time trying those example problems that I gave you, in which case, maybe you've got about an hour left just for practice, for challenging each other. If you get tired of your buddy, you can switch buddies. That's true. So that's what we have today. We just need practice. We need a lot of practice. And hopefully going through some of these example problems has helped you. Remember that there are solutions to those giant problem sets posted in the calendar as well. So find those and make some enemies. All right. Thank you, guys.